United States, they knew it makes sense, energy-wise, to orient your building with the long axis east and west, so that
most of your lighting and your windows face either north or south.
Second, thermal envelope.
The building was built out of a product called Reward Wall. It's an insulated concrete product.
The R value is about an R27 just for those forms. The overall wall insulation value ends up being about an R33. Typical windows, you're looking at a U value in most buildings of about a 0.5. Utilizing low E-coated, argon-filled, triple glazed, thermally broken frames in our fenestration systems, we've improved that by a little over 50%.
The windows were going to cost $15,000 extra. The developer right away, initially said, whoa, that's too much money. We can't afford to do that.
We were real skeptical that we could get our numbers to where Jim Toothaker said we were going to get them.
But when you take into account that the perimeter heating system was then able to be eliminated,
you basically save $15,000. But the story doesn't end there.
And there was the subsequent downsizing of the central HVAC system,
which also affects the duct sizing and the pipe sizing.
The costs garnered from that roughly were about $25,000. So spending the
$15,000 for the windows resulted in a net
savings of 10 that we then utilized to put better insulation into the roof. The roof, by utilizing 4 inches of rigid insulation on top of R5 Homosote decking, we're up at a little over R30. Third, lighting.
Lights not only generate light, they generate heat. There was a design focus on daylighting with Cambria that wasn't there with South Central. We wanted to daylight the spaces where the people are working most of the time during the day.
We set up light shelves and different things like this that bounce natural light in.
The light shelf acts sort of as an overhang to keep the high summer sun from penetrating into the room.
What we've got are high clerestory windows in the center of the building and low exterior punched openings in the wall on the north and the south sides.
We tie our daylighting to light level sensors
that take the artificial lights and dim them down when we have adequate natural light coming out.
Using the Watt Stopper isolés that'll turn off the task lighting in the workstations, and also using motion sensors in some of the other common areas of the building, the bathrooms, conference rooms. You're simply trying to not use energy when you don't need to.
I was notorious over the years with landlords for saying, I don't care how you do it, I want 73 degrees.
It's almost an axiom in the engineering profession.
I don't care how hot it is, I don't care how many people are in the building.
Nobody ever got fired for oversizing a system.
I don't care if you have angel wings beating over blocks of ice, I want 73 degrees always.
People get fired when the systems don't work.
One of the changes that we've made is we're saying we want the buildings right-sized.
So that it's the proper size for the task, rather than over-engineering and over-designing these things.
This is, to my knowledge, the very first time that a ground source heat pump system has been coupled with an underfloor system for the HVAC purposes.
I fought that from day one because I'm a sheet metal specialist. I like running ductwork. It's what I've done for 30 years. And when they proposed to me that I'm going to blow air in underneath this floor, I laughed at them all the way through. I said, it'll never work. We took all of our air handlers, we put them in a mechanical space, so there's a very minimal amount of ductwork. I've had to call Harrisburg and tell them that I was very wrong, that this was the best system that I've ever installed.
Never going to work.
Yeah, but once you experience, you won't say it again, though, will you?
No, we learned something.
And in a way, that's how an artificial system starts to mimic a natural system, like an organism.
Because even to do the sizing of the system, you needed the loads and you needed the envelope. Orientation.
There's operating conditions also.
One way you can measure the energy cost of systems is the energy modeling.
The real advantage of the model along the way is that it accounts for the indirect effects of a change in the building as well as the direct effects.
You can look at different glazings, different R values, different HVAC systems.
You can say, okay, let's add another inch of rigid insulation to the roof. Put that into the energy model, which then synthesizes the new energy cost annually for this building.
Modeling gives you the ability to play what if on a scientific basis. In Cambria, we agreed to pay the energy costs So we have a very real concern of what those costs turn out to be, and we obviously then have a real concern that all systems function as they're designed to function.
Ask any architect whether or not the HVAC system has created problems for them post-occupancy, and I think you'll get 100% yes response to that.
Commissioning illustrates a failure on the part of architects and engineers to truly follow up with their design.
All going to the last night.
The key to commissioning is doing design phase commissioning. If you can establish the performance criteria for the job, you can affect the way the process goes together.
So ultimately, those dollars spent for callbacks to fix problems are virtually eliminated.
You really don't know what your operations are actually going to function like until you monitor and know where the energy is being used and how. After 9 months of information compared with the average annual cost for energy of northeastern office buildings, we're finding that we're currently operating at 48% of those numbers. With our monitoring equipment in place and with the operations of the building, I think we'll see a decrease from where we are right now down to our model level and even below the model level, and that number does not include the impact of the PVs.
This is the second largest photovoltaic array in the Commonwealth right now. Not likely to be so for long. There's a 400 panel array mounted on the roof, and then there are 2 trackers out in front of the building.
It's going to be a generation facility, and we'll literally be selling the output of that to Green Mountain and buying a very green form of energy for the building itself.
We have a renewable energy requirement in our purchasing for state office buildings, hospitals, and all the things the state runs, and we're going to increase that over the next couple of years. That's important. It makes business sense to develop photovoltaics, wind farms, to go to renewable sorts of energy. That's something we want to encourage by our own actions.
And I don't think we did a particularly good job at all in integrating materials. I mean, all it was let's see what we can slap into the lobby to demonstrate some of this stuff.
Yeah, that's how I came
into
the point, yeah.
Well, yeah, but don't be too harsh on yourself. South Central was built to exhibit materials and what they were like so that people would get a little more comfortable around them and some of those things.
Because those materials are a statement of the thinking of that whole project. We don't have to just do sheetrock here or just granite here. Let's take a leap and say this soybean and recycled newsprint stuff might work.
It was a pretty different process once we went to Cambria.
We integrated those materials right into the fundamental needs of the building as opposed to where they were largely, and I love your word for it, iconoclastic.
Right.
We had the USGBC's LEED process. That helped us considerably. We also have some of the very best sustainable materials people here in Pennsylvania that I'm aware of across the United States.
You don't. I was asked fairly early in the project to come up with a list of some of the things we'd want to begin with, and everything on that list ended up in the building.
We virtually doubled the high recycled content materials in Cambria over scrub.
Because we knew more about it, because we had more confidence in the products.
Getting systems furniture manufacturers to use the 100% recycled soda bottle plastic fabric on their panels. And wheat board as their countertop substrates.
With the agricultural particle boards, you have materials that take about 3 months to mature, as opposed to tree particles, which take about 60 years to mature.
A developer has to pay attention to the products that he's using.
The recycled rubber flooring.
The wheat board wainscoting.
Fly ash concrete.
Nylon carpet tiles. Recycled steel.
High reflectance ceiling tiles.
Ergonomic seating.
The most sustainable material is that which you don't use. Exposing all the structure on the second floor and using a reflective decking system made of Homoso, which is 100% post-consumer waste paper.
Almost all the recommendations cost equal, if not less, than standard materials.
There's not just a cut and dried approach to build up a green building.
It shouldn't be static. It shouldn't be this perfect thing out in the middle of this industrial park.
One of the lead things is how many materials you use within 300 miles.
Driving back and forth from Harrisburg to the building location.
You see hemlock on 150-year-old barns that was never painted.
What if we use just hemlock siding like those barns?
There's very little energy to go get that log out of the forest.
It was harvested from local woodlots and sawn locally at one of the local sawmills.
And then we didn't go to the extra step of drying it. It's basically drying as it sits on the building.
And I'm not saying you should do that for every building, but for this particular building, that was a real good answer.
And what that other piece does is block off the hole.
Right. Everything we're trying to achieve is really aimed at how can we improve that indoor environmental quality so that the spaces that people have to inhabit most of their waking hours is a positive experience.
You want to make sure that the daylighting systems produce comfortable levels of lighting.
Daylighting works best when the light is coming from both sides of the room, both the south and the north side.
You don't want high levels of contrast because the human eye doesn't respond to that very well.
That new car smell that you think, oh, this is great, that's really solvents in material evaporating.
We're using paints and adhesives that have low or no VOCs.
The underfloor plenum distributes the air through Kronz diffusers that stratify the air at about 2 meters.
Our monitoring equipment monitors not just temperature, but relative humidity and CO2 levels.
Carbon dioxide in the outdoor atmosphere is typically around 350 parts per million.
CO2 is a very good indicator that you have an adequate amount of fresh air coming in, providing you have a realistic level set.
And that's why the green building specifications require levels below 700 parts per million.
If people are comfortable, they're going to want to come to work more, and they're going to want to stay at that particular job more.
You talked about life-changing. For the 14 years prior to this, I was primarily concerned with aesthetics. Now, all of the different issues that we deal with are more informed by an even more wonderful aesthetic.
We don't have to continually pay the price for being a throwaway society.
The green way is a better way. It's going to last longer. It's going to save that tenant or owner money in the long run.
If you have a building that's using less than half of the energy, that dollar and cents argument makes a lot of sense to people.
Most of the times government talks and talks and talks. We're actually doing and accomplishing, and that's how we're leading.
If you lead by example, others will follow, and I think that's really the most effective thing that government can do. I think we're going to accomplish even greater things in the future because of that.